Okay, in this video, we're going to talk about constraints in HiFi engine. Because HiFi engines has many different material models and we do allow them to be fully coupled, we try to design constraints as unified as possible. So some of the options to create constraints and how constraints behaves might be different from other simulation engines. But the reason for that is because we're trying to make things as unified as possible so we don't run into the combinatorial issues. There are a few constraints that are only supported by some specific types of objects. For instance, the root constraint is only supported by the elastic rod. You can refer to the hair and elastic rod solution for root constraints. We'll not go through that here. Affine body has a special type of constraint called joint constraint, which we'll go through them later. And all the other constraints are supported by all the Lagrangian object types. NPM meshless particles right now does not support constraints. So with that out of the way, let's take a look at the point constraints first and as a review. So you will know that the HiFi engine constraints are right click and you can find the constraint menu, and you will see that in object mode the constraint menu looks different than the constraint menu in the edit mode. It's because in edit mode, all those constraints provide options to allow users to select some points or edges to bind constraints. While in object mode, it's under assumption that a user will want some automatic binding algorithms to either project the points onto the closest surface or some other algorithm to automatic binds find the closest points for constraint. So point constraint only supporting any mode for obvious reason, because point constraints you want to only bind selected points. You had to select point in the edit mode, and when you select point and point constraint, and you will see the constraint object here. And the constraint object is drawn in on the 2 points. And as I mentioned before, all the constraints are stored as per vertex, or sometimes per edge, depends on what type of constraint is. But basically, per constraint, it has stores like all the attribute informations, such as where the position are, the weights, barycentric weights. So what's interesting about HiFi is HiFi does not just allows people to constrain points; it actually allows people to constrain any point on the surface. So we can do barycentric. Then you will see the binding positions that happens, and then some of them also have rest length, and with also the binding indices. So it tells HiFi engine what the indices are. So there goes the rest length. So it will tell the where the indices are. So inside the solver knows what points are being constrained. All right. So that's kind of the general idea. That's also why there isn't a way to remake easily like update the constraints, because you need to know all those binding information that doesn't, like, user may not know, right? Those binding data are coming from the time of calibration, which once you're animating things and can get a little bit wonky. All right. So that's that. Let's move on to mesh constraint because that's more interesting. So let's create a cube first. So mesh constraint technically internally is a type of 4-point constraint. It just now the point follows the mesh itself. So let's add a triangulation to the mesh. So point constraint, what does is just find the point and constrain the pointing space, right? You can manually animate in the points, but that's not particularly interesting. But what happens if you want the simulation object to follow a deformable mesh? So then you need it's a mesh constraint. So we just select objects, select a mesh, and the distance between them is about half. You can see that half the grid. So we're just gonna create mesh constraint, and because we're in object mode, it's just going to try to automatic bind. So let's try 0.6. There it goes. So you see now there are 3 points here being constrained, because they're within the point, and then they're constrained onto the surface. So if we key the animation of the object and move, and then run the simulation, you will see the a point constraint automatically follows the object. So that's so you can imagine it does what it does is that's why the object need to be triangulated. So it does is compute barycentric point on the object and then do a local coordinate. So it actually allows some offsets to it as well. So it's always supports that offset. There it goes. And you can do the same thing and delete that. And if you have that in the edit mode, you can just select the point and then mesh constraint, and you will just automatically use the selected points instead of trying to do a radius binding. So that's that. Oh, actually, we also select those two. Yeah. Okay. So that is mesh constraint. Pretty straightforward. The next thing is binding constraint. So the binding constraints are, let me open up a new scene. Okay. I think the tests, binding constraint test. Actually, curve binding. This is more interesting. Okay, so this is a pre-setup thing. I have a curve simulation and I have a, let me move away the cursor. All right. So I have a curve, two curves here, and a affine body. So the cube is just affine body. Let me delete the binding constraint, sure, correct one. Okay, so what are these set up here is an edge. So this is not a hyphy object. This is just like a mesh. And how I did this is I grab the points and then you will see the snap to vertices. So I just snap onto the vertices. Say, okay, I want this point of the affine body bind to this hair points, etc. It doesn't have to be binding constraint doesn't have to be on vertices. Just with the vertices for snapping, you can actually bind any place on the edge if you wanted. So what is interesting in this case is we allows the user to give kind of a topological information, right? So the user can provide a mesh that is connecting two simulation objects, and then we're going to use that object, that mesh, to bind the two simulation objects. So right now we have no mesh constraint at all. So if we run the simulation, let me just run the simulation, you will see the cube that's its own thing, and the we need more frames. Let's see, 20 is enough. You will see the cube is doing its own thing and the hair is doing its own thing. So now if we just select the planes and select the object and select the edge object you want to, and you can right click and convert edges to binding constraints. So what this does is it's basically saying I'm going to use this edge to bind the curve onto the object. And then there are a few options. The binding tolerance is saying how close the point on the mesh should have to be considered on the mesh. Its small tolerance is fine. But if your scene is pretty far, you probably need to increase the tolerance a little bit. So the idea is that the point is landing on the curve or landing on the each end of the point edge is landing on the curve and landing on the objects. And you can override the rest length. If you do not override rest length, it will try to keep the edge length as the rest length. If you do, you can basically pick a rest length you wanted. It can be very useful if you have doing stitches that you don't like. You have two cloth pieces, which I'll show later, very far away, and you don't want the rest length to be that far, right? You want the rest length to be shrinking. So this is what that's for. And then, but in this case, we just want to keep it to show that's how the constraint works. All right. So now the constraint is created. It's here, and then we run the simulation and see. Oh, and you will see the constraints and following. Let me hide the object that it was using to create the constraint. Okay, it's called the plane. All right, and then you can see the constraint object. And constraint object has something very live update. So for binding constraint, because it's internal to the solver, it doesn't always need to have anything. It doesn't need to update in the scene. So you will just not see it moving. However, we provide the debug information here called live updates. So if you check it out and you animating a frame, so you can see how the constraint object is impacting the scene. So that's very convenient. That's about the edge constraint for two separate objects. Converting edges to binding constraints for two separate objects. The reason you have to do this way is just because this is a curve, this is a mesh. You can't create a mesh edges within them, so you need the separate edge objects to bind them, right? So that's why you need three objects. However, let me open the dressing demos and the Taylor scene. Yes, the Taylor. Okay, so in this Taylor scenes, something more interesting is that this is actually one piece of cloth object, right? And this is very similar to within Blender. So within a cloth object, you could have just create empty edges to bridge the corners. You can bridge the gaps, right? I want this edge to be stitched to the back, and then I can create just empty edges, and then the edges will be considered as some type of stitch. And this is the same here. HiFi Engine allows you to directly convert all the edges into the binding constraints. So if you right click, we already have a stitch here, but I'm just going to create again. So you can do the edges to binding constraint. And then you have the same option, but right now, because it's only one object, it just says single object with straight edges. So what it does is just using all the straight edges within the object as a binding constraint. So this is in object mode. In edit mode, something far more powerful you can use. So I believe I do not have that. Okay, it's fine. So in edit mode, what you can do is you can select. So let's say we just want these stitches, because we may want to separate out different type of stitches into different constraints to control their parameters if you don't want to paint them, or different timings, right? So we just want those to be converted. So if you right click, HiFi Engine convert edges to binding constraints, and then okay, now only the select edges. Let me hide the cloth. See, this is the newly created constraints. Only the selected edges will be converted to that set of constraints. So using this way, you can also using vertex groups, basically to mark down which group up different type of stitches and create the constraint separately. And it's that's how that's how the dress is created. You can see there are different type of stitches in the cross stitch, and have a different rest length, and then those non-rest length stitches. So let me show you here. So there are two types of stitches here. Okay, yeah. So in this scene, we have the cross stitch sides. So you can see the zigzag ones. And when the cloth being pulled together, unfortunately, I don't have the simulation here, but you can imagine when the cloth pulled together, those will have a different rest length. So if you look at the geometry node, and you can see they have a rest length of 0.01 because it's a meter, so it's about 1 centimeter. One centimeter and some small value here. You can see a tutorial how the length is calculated. While the rest of the constraints just pulling the sides are just pulling things together. So if we hide it, they're drawing. So those are just gonna pull everything together of the same length. So if you look at this one, it's actually half a millimeter, right? So different set of constraints will have different rest length. So in this way, you can separate out the constraints based on their properties and control them separately. And in this case, the criteria for them is the rest length. So that's the convert edges to binding constraints. Let's do the next one. Okay, so There is another way to do binding constraints, that is using the create bind constraint. So actually it's better to separate them. Let me find the file that have them separated. Binding constraint, that one goes. So let me hide this. Yeah, so another way, as just the mesh object, another way to create binding constraints is just automatically allow the algorithm to do it itself. So let me hide the underlying grid. So you see, like they're about 2 units two subunits, so 0.2 away, and now I can select them and then create binding constraints, and let's see 0.25. I think that's enough. And there it goes. We're going to override the rest length, give a little bit. So what it does is that they look at the 2 objects and then just going to find the closest points that within the radius and bind to them. The reason that I did want to using the examples of 2 separate, because you can see if you only have one object, the object can bind within itself. If some vertex is too close, it can bind with itself, which is undesirable. Again, this is just a different way to create binding constraints. All of those binding constraints are the same. So if you do this, you see the binding constraint here. Yeah, let me delete the one. So yeah, like that's very straightforward. They just find the closest one, and then if we simulate it, because we use a very small resonance, it's gonna put them together. Yes, and that's the expected behavior. Yeah, and that is on binding constraints. We're going to go through the join constraints and animate constraints next. And I think this video is not enough, so see you next time.